Welcome to this explainer on Java file handling, where we're going to completely bridge the gap between temporary memory and permanent data storage. Look, if you've ever written a program, run it, and watched all your hard work completely vanish the second the console closes, well, you are in exactly the right place. Today, we're going to fix that for good. So let's dive into this universal programmer problem. We have literally all been there. You build a stellar application, your user inputs a bunch of data, you do some complex calculations, and then, poof, the program ends and everything is just gone. It's the absolute tragedy of volatile memory. Your hard-earned data just vanishes the exact second your program process terminates.
The way out of this trap is a concept called FileIO, which stands for input and output. It's the ultimate solution for taking those temporary program results and locking them in permanently. In Java, this whole thing is entirely powered by the built-in java.io package. That package hands us all the classes and tools we need to save and retrieve data reliably right from our hard drives.
Here's our roadmap for this explainer. 1. The power of FileIO. 2. Meet the file class. 3. Creating and inspecting files. 4. Writing and reading data. And 5. Deleting and wrapping up.
All right, part 1, the power of FileIO. Let's talk about why we actually need this.
You know, FileIO isn't just about saving basic text. It is the absolute backbone for managing real complex systems. Sure, we use it to store data permanently and read it later, but it's also exactly how we save program results, manage application states, and handle system log files. Just think about saving student records in a school database or remembering a specific user settings. Literally none of that happens without FileIO.
Before we even glance at the syntax, I want you to mentally bookmark these 5 steps. This is your checklist for pretty much any file operation in Java. First, import the java.io package. Second, create a file object. Third, set up a stream object, like a reader or a writer. Fourth, actually perform your read or write. And fifth, and I can't stress this enough, close the stream. Lock that flow into your brain and you'll never get lost.
Moving right along to section 2. Meet the file class. This is our foundation.
Okay, so a crucial mental model here is the map versus territory analogy. When you use the file class in Java, it does absolutely nothing to read or write the actual data. It merely represents the file or the directory path. The file class is just the map, right? It's the blueprint, the pointer. It is definitely not the actual physical file sitting on your hard drive.
Let me show you what I mean, because honestly, this is a massive pitfall for beginners. If you write this single line of code, file f equals new file data.txt, you are simply creating a file object inside your program's memory. That's it. It leaves your actual hard drive completely untouched. To genuinely create the physical file on your computer, we have to take things one step further.
Which brings us to section 3, creating and inspecting files. Time to actually build something.
Once we've got that file object, Java gives us a massive toolbox to interact with it. We've got Create New File, which finally builds the file on your physical drive. We have Exists to safely check if a file is already sitting there. You can use Length to find out exactly how large the file is in bytes. We can pull its name, and we can even check our system permissions using CanRead and CanWrite. So let's look at the code in action. Notice how we're dropping the creation process right inside a try-catch block? That is mandatory because dealing with external files can always throw an I/O exception. Maybe your hard drive is totally full, or maybe you just lack permission. But if it all works out, our if statement calls file.createNewFile, actually writes the thing to the disk, and prints file created successfully. Once it's created, we can really inspect this new student.txt file. By first checking if the file exists, we dodge a bunch of potential errors. From there, we pull specifics, its name, its absolute path, like C drive, Java folder, student.txt. We verify it's readable, and we can confirm its size. Like if we just wrote a quick sentence to it, it might return a length of 45 bytes. And speaking of writing sentences,
Let's jump into section 4, writing and reading data, the fun part.
remember how we said the file class itself doesn't actually touch the data? Well, Java divides that labor up nicely. The FileWriter class takes data from your program and shoves it into the file. On the flip side, the FileReader class pulls data out of the file and brings it back into your program. Writers put information in, readers pull information out. Super logical. Let's check out the FileWriter first. We set up a FileWriter object specifically linked to student.txt. Then, we simply tell our FileWriter to drop our text into the file using the write method. You can even toss in line breaks using a \n.
But hey, look at the very bottom line inside that try block. Writer.close. This is critical. If you don't close the stream, your data might not actually get saved to the disk, and you'll lock up system resources. Always, always close your streams.
Now, pulling that data back out is just a little bit different. We set up a file reader, but instead of just gulping down the whole file at once, we use a while loop. This loop keeps pulling data, character by character. It takes the character, converts it to an integer, and checks if it equals -1. Why? Because in Java file I/O, a -1 literally means you've hit the exact end of the file. So it prints each character until it hits the end, and then, yep, you guessed it, we call reader.close. Finally, Section 5, deleting and wrapping up. Time for some cleanup. Honestly, cleaning up obsolete files in Java is wonderfully straightforward. You create your file object blueprint, pointing it right at the file you want to target. Then, you just use a simple if statement with the file.delete command. If it finds the file and deletes it, it returns true, and we print file deleted successfully. It's just a totally clean single-method operation.
Stepping back to look at the big picture of everything we've covered today, the advantages here are just massive. Your data is finally stored permanently. It's incredibly easy to read and update those files once you get the hang of the core methods. And frankly, these file operations are the exact tools used in pretty much all real-world applications. They ensure your data storage outlives a simple program cycle.
This quick summary table perfectly captures your new core vocabulary for Java file management. File I/O is your overarching process. The file class is your blueprint. Create new file makes it real on the disk. FileWriter pushes text in, FileReader pulls text out, and delete just sweeps it all away when you're done.
So, now that you absolutely know how to conquer volatile memory and make your data permanent, I've got a question for you. What real-world Java application are you going to build first to store your records? A habit tracker? A student database? The power is literally completely in your hands now. Thanks for joining me on this explainer, and happy coding!